So we're doing 11.8, which is rotations. You guys just did your vocab. We had a rotation, which is a transformation where a figure is turned about a fixed point. The center of rotation, that is the fixed point. And then we have the angle of rotation, the rays drawn from the center of rotation to each point that the image forms this angle. And then we have rotational symmetry. If a figure can be mapped onto itself by a rotation of 180 degrees or less. You guys have dealt with 360 degrees, right? You know that one? Okay. Oh, I didn't finish that. It is. So we have 180, which is the next one, right? So symmetry that occurs within 0 to 180 degrees. That's what we're talking about here, rotational symmetry. Hey, our next one is we want to see if these have rotational symmetry. Does a rectangle have rotational symmetry? And we have to answer that. So, does it? And we see yes, it does, right? This is your original. I turn it 90 degrees. No symmetry. I turn it 90 more degrees. I get symmetry. So, we say yes, it is. Hey. How many degrees did it take for it to get back to its original?
How many it took to get back to it?
180. Okay, so I'm going to draw a clock on the side of this. If I draw a clock here, we have 12, we have 6, we have 3, we have 9. Clockwise, CW goes this direction. If you're struggling with that, I have a clock in the back of my room. If you see the way the second hand turns or the minute hand, you can see that. We also have counterclockwise. So counterclockwise means we're going this direction. Okay, CCW and CW. So over here, when we turned it 180 degrees, which direction did we go? We did clockwise, right? But could we have also gone counterclockwise?
Yes.
Yes, we could. Counterclockwise. Okay. I have a trapezoid. Is there anywhere between 0 and 180 degrees that I can turn my trapezoid to get it back to the original? No. Nemo's shaking his head no. He is correct. No is the answer. And we say does not have rotational symmetry. Since it cannot get back to its original shape within 180 degrees, say it does not have it.
Random question. Can I ask it?
So our original picture here is this R. So you have R right here, and this is my original picture. Over to the side, I'm going to draw a circle. So if I am at 0, 90, 180. So if I am rotating clockwise, and my original figure is here, and I go 90 degrees, I'm now here. If I go 180 degrees, I'm now here. I'm upside down, right? So we're going to see what we can get with these. So if we go 90 degrees clockwise, which figure are we arriving at? We arrive at C. So we have 90 degrees clockwise. We take this picture, we pick it up, and we turn it that way. We get C. We have 180 degrees clockwise. So which figure are we going to get? You're going to get A, right? 90 degrees, we're here. We go 90 more degrees, and it turns. We get A. What about if we did 180 degrees counterclockwise? You arrive at A again, right? So now you're rotating this the other direction. So you go here and then down. And then the last one is 90 degrees counterclockwise, and I hear Lucas saying it's B. So you notice if you take this and you turn it to the side one, you get B. Another math teacher told me she'd use this as like turning a door handle. You have it here. 90 degrees is what opens it, right? But 280 is too far. You can go the either direction. Okay. Yeah, that's true. Okay, we want to see if the picture has rotational symmetry. Does it have rotational symmetry? So our first picture, the isosceles trapezoid, is there anywhere between 0 and 180 that will get back to the original photo? 360 would, but we're only looking for 0 to 180. So 180 would then put it upside down, and we'd see that these pointy ends up here that are really long would now be on top, and the short end would be on bottom, so it wouldn't be the same. So we say no. Okay, so for the second one, our parallelogram, do we have a point where that would be? How far? If we went 90 degrees, it would then go from here, for this side would now be on top. Would that be the same? Mm-mm. So how many would we need? 180 in which direction? So 180 degrees clockwise. What else can we do? 180 degrees counterclockwise. Okay. Our next one, our octagon. Does it have rotational symmetry? It does. So we can go 180 degrees. Which direction? So we have 180. We have what else? We aren't going all the way there, from 0 to 180. We have 90. There are two more. I'm not going to put something like that on your quiz, but does anybody know? We have 45. Not going to be 30. So if it's at has it at 45, it's also going to have it at 135. That's 45 degrees plus that 90. So 135. Again, I'm not going to put one that's not 180 or 90 on your quiz. But so you are going to have a quiz, and why we're doing 2 lessons today is because you're going to have a quiz on Friday. It's going to be a very short quiz. Tomorrow we're going to spend the whole day reviewing. Okay, this is already written on your page. So I would star it. This is like, I want to make sure I remember it. Good information. So if it is 180 degrees, so if you have a coordinate point, it's normally an x, y, and it's 180 degrees, what we do is we put a negative with the x, put a negative with the y. If we have 90 degrees clockwise, we switch the y and x, and we put a negative with the x. So we just switch the sign. And then our last one, 90 degrees counterclockwise, we put the negative with the y and switch the x and y. So let's do one of these. Okay, so I'm going to graph our original points to start with. So I have A, which is 2, negative 2. I have B, which is 4, 1. I have C, which is 5, 1. And I have D, which is 5, negative 1. Okay. Oh, sorry about that. Okay. Now I'm going to graph my next group. So I'm going to have A prime, B prime, C prime, and D prime. We are going counterclockwise. So since we're going counterclockwise, which one of those formulas are we using? So if we're going 90 degrees counterclockwise, so it's going to be that negative y comma x. Okay, so I like to do all of this at one way. So I'm going to do all my y's and I'm going to do all my x's. So I'm going to put my parentheses for each of them. So it's going to be negative y, so just the opposite sign of y. So since it's negative 2, it's going to be positive 2. Since it's 1, it's going to be negative 1. Since it's 1, it's going to be negative 1. And since it's negative 1, it'll be 1. And then whatever my x is now becomes my y. So I have 2, 4, 5, 5. Now we are going to graph these. So we have 2, 2. So that's A prime. We have negative 1, 4. That's B prime. We have negative 1, 5. That's C prime. And we have 1, 5, which is D prime.